is that the size of the ZFS ARC cache really affects the behavior of VM2. So if you're using UFS for everything other than the boot, then tune the ARC cache right down. That is important. The other thing about MDB, I've done quite a lot of work with the engineering group, and they're great guys, they really care about quality. They really have built in some great diagnostic tools, and you should never usually know VM2 exists. What's important about VM2 for you? Well, lets you to have much bigger memory machines. And that's kind of, and many of the algorithms will scale. And we should get rid of some of the edge cases, so some functional and performance edge cases. But for us, it's one of those things, if you think about diagnosis, how the support for diagnosis has been built in. But if you are either psychopaths yourself or run workloads which are in that category, can you please upgrade to SRU 7? File systems are hard to write, and I've just done an integration into UFS for in Solaris 11 update 2 and Solaris 12, and I'll be breaking update 1, I hope not. With this for UFS. And whenever you make a change, and UFS is kind of creaky 25, 30-year-old MSC project. And when you make a change, it's a dance between avoiding race conditions and scalability and starvation. And any file system is this dance. And it's the same for ZFS. I think maybe VXFS was probably conceived in a mosh pit at a heavy metal concert. I don't know where it was conceived, but all file systems will have the same issue. They're hard to write, and it's relatively easy to expose race conditions and edge cases. But if you look in terms of performance, one of the things that is most useful for particularly ZFS, and I guess also UFS, is lock contention. And most of the scalability issues I've seen for ZFS where we have a workload we haven't yet seen, lockstat is really the best way to go. You'll see high SMTX, so to speak mutex, contention in MP stat, and go off and look at -C on lockstat, and that may give you some indication in ZFS. Also, ArcStat can be quite useful for working out how the ARC is performing. And if you've actually set ZFS ARC max, what's the right value? You know what the right value to set ZFS ARC max to is. Pardon, Phil?
Depends.
It depends, yeah. It depends on lots of things. Depending on your workload, the size of your machine, and that. And it's one of those things you kind of got to guess and test.
It's 2 times the swap.
2 times the swap. Oh yeah, it's always 2 times the swap. Dear. Right. I believe all presentations need a marketing diagram.
Very nice.
Very nice, isn't it? So I can't remember where I got it from. Anyway, moving on. I'll show you some more stuff about VM2 later. So, this is kind of Clive's hobby horse at the moment. How many people run 10 gig at all? You don't count. 2, 3, 4, 4. You don't count.
I do.
Have you performance problems with it yet?
That's all slow.
Pardon?
It's all slow.
It's all slow. Okay. So one of the things I've observed in a few of these issues is that it's quite easy to saturate a 10 gig server, sorry, a 10 gig switch to get it to drop packets, and it's quite easy to have multiple clients to saturate a server connected at 10 gig, even if it's got multiple interfaces. Hosts with multiple interfaces are now getting more and more common, so this brings in all this IPMP aggregation, LACP madness I don't understand, but I suggest would be a really good, if you can get somebody, I could help you find somebody maybe, who understands this stuff in appropriate detail, I'll come along. It'd be a really good talk, because I think this is a can of worms that is hard to get right, and we and switch vendors are conspiring to make it more and more difficult. Maybe it's just the standards committee.
Don't you think that in a way it's a bit that it is meant to be so simple that you can compose all these things together, and you can sort of have IPMP, and then you can put aggregation on top of it, and you can put on top of that, and on top of that, and on top of that. So you can build up as complicated as you want just by putting these quite simple components together.
Yes. And I think that, yes, and because observing what's going wrong is somebody else, is from a server point of view, we have to rely, we can't put a network tap on ourselves. Switches don't hold, some switches don't buffer anything. They just forward packet. It is really hard to prove who's dropping packets. And that's kind of the bit I'm interested in. But complex, again, I think it should just be regulated. You shouldn't be allowed a machine with more than one interface. But the complexity is it's great. It's work creation. Let's not worry about it. My problem is I don't understand it, and I think every so often you come across things you realise, ooh, I really don't get that. So I intend to spend some of next week tracking down people who do, and go, right, sit down. Here's a coffee. Talk to me about LACP.
I think, Clive, too, also people are tuning for specific checkboxes on their product. So some people care a lot about low latency, some people care a lot about throughput, and some people care about specific features within standards, but they all care about different things.
Yeah.
And you alluded to the millions of lines of code that are involved. So if you're only focusing on a subset of those, and different people focus on a different subset, then it's always going to be painful. Which is why how many flavours of InfiniBand? Oh, we'll just go for this one.
Good. I think the other thing here is a maturity of technology. So anybody here like to buy a fully configured M5? We'll send somebody to site with you. You buy it. We'll send someone from engineering to make sure it's done right. Okay? So, that's an early set machine. Yeah? Okay, problems happen. Be there, sort it out. 10 gig could have been around a while. Some of the switches been around a while. Maybe second, third, fourth generation. So we're not sending anyone out. Other vendors are not sending people out. It's more mature. Which means that it's up to the customer to set it up. And for example, some switches have bandwidth limitations set by default, where it will just throttle, even for if you have multiple feeds. And those need to be set up, and they're not being set up. And there can be lots of things like this. And so I think data center class switches are really not plug and play, but they're being treated as almost a commodity switch. All right, a big commodity switch in a big rack, but they're not being configured. The whole technology and integrating it as a system is, basically means there are bad choices. Nobody's setting out to do this. People aren't stupid. I've met very few stupid people in this industry. I've met very few people who make bad choices intentionally or for selfish reasons. It's that these things are incredibly complicated. And I think if you are having 10 gig network issues, getting someone in to review the kind of systemic, or finding someone if there's someone in your organisation, that the system to review how it all fits together, and whether the communication between the switch and the clients is set up properly. And again, world I don't understand. There's a really good case for that. But this is into the lower part of the iceberg. I'm sure you can tune switches to get 1 or 2%. That's not interesting. It's when you've got, you expect to be able to get 40 gig out of the switch, and you're only getting 10. That's the bottom of the iceberg. So, how many people use NFS? Anyone use NFS on a 10 gig? Whoa! You don't count. So NFS can really be a bursty workload, and if there are components, so imagine you've got something that's doing large transfers, so you're reading files and you set so the NFS read ahead and the NFS buffer size, you can happily read 256k. So NFS can make 256k requests, and this can fill up switch buffers, particularly if you've got multiple clients. You can overrun the NIC, you can start dropping packets if there's any kind of delay.
Yeah, we've had quite a lot of that.
Yeah, we should talk. And NFS will suffer greatly where packets are dropped. And there has to be retransmissions, because you get TCP, good stuff, the exponential back off. So that you can drop stuff at the switch, again, very difficult. Beware of switches with interconnects, where one switch has to pass to another, and those interconnects can be really awkward and really hard to diagnose issues, and switch vendors are very reluctant to admit to them. Client NICs can be dropping packets. There are certain NICs that there's kind of this technology continuum, is that you think that of where 10 gig for certain classes of machine, if that machine had already been out 2 or 3 years, and a 10 gig card comes along, it's qualified for it, the machine may actually not be able to drive or receive at full pelt from that card, and that could be a result of dropping packets. And again, a server, if you've got enough clients hammering it, it can start dropping packets. So one of the netstat-s is really useful. Now, I thought that there would be a description of what all the fields in TCP part of netstat-s are. No. It was really good having somebody on the TCP Standards Committee sitting next to you to explain what they all mean, but they're not that portable, these people on standards committees. So one of the things I'm certainly going to look at doing is trying to document some of these, but basically you're looking for things like drops, segment drops, duplicate acknowledgements, and that what you're getting can explain. You can then say, oh, well, that explains. Seeing this behaviour in netstat-s suggests it's a server issue, or suggests the network is dropping packets, or that the client is dropping packets. So that's quite something to be aware of if you have NFS performance issues, or you want to improve. That could even be tuning NFS performance. Also looking at some of the TCP case stats is quite useful. We'll have a look at a couple of them later. And also at the NIC. And there you're looking for things like drop. One of my favourite commands is kstat-p grep, and then things like drop, retrans. And if you do have NFS issues, then that can be a good place to start. So one of the other things is that actually tuning larger and larger buffers for NFS can be counterproductive, because you end up into these bursts, and if your network is not fully capable or there are bottlenecks in there, packets get dropped, TCP backs off, and again it's an exponential back off, so you can actually be worse off by having big transfer sizes than smaller transfer sizes, and that can happen. And think very, 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 very hard, certainly in recent Solaris 10 and onwards, about using bound soft rings. So the whole point of the soft rings was to basically simulate and jumbo frames is good for NFS typically. So I've seen a customer set to 8,000, set jumbo frames to 8,000 when a page and the buffers were 8K, so 8192. I didn't really get a good explanation apart from something to do with interrupts, but the standard is 9,000. That'll typically be what we test.